wrong, but we didn't
Okay.
know how.
Yeah. So you could have said each person high-fives 5 other people and halve it to double count, and so you get 15. I just want to make a few observations about this. First of all, you know more than you think. That's a really important thing to remember in classrooms, to get children to take risks. It's amazing what people know when they actually sit down and think about it. Secondly, it actually helps to work in a group. The days of sitting in a classroom doing pages and pages and pages of add-ups, hopefully, is gone. Are gone. Children need to talk, they need to work together in maths as much as in anything else, or perhaps even more so. Some problems have different solutions. That wasn't one of the, I mean, they actually had one solution, but they had different ways of thinking about it, like that. This didn't come out of that activity, but occasionally you get problems that don't have any solutions. There's almost always more than one method to solve a problem. So that's just a few observations about that. And that one probably didn't come out quite either, but it will in the tutorial. Problems that look different are often actually the same problem. Let's just talk a little bit about some stuff about problem solving and a little bit about, maybe I should have got Ian to do this. Is it?
No, you're right.
No, we're right, okay. But chip in when you need to. Polya was a mathematician, did lots and lots of research about how people solve problems. He came up from his research saying that people take, that when you solve problems there are almost always 4 steps. There are others as well that other people can add, but Polya's 4 kind of simple steps were these. First of all, understand what the problem's actually about. In the case of the high-fives, it was understanding whether that counts as 1 or 2, or how we were going to do it and how we were going to count them. Actually, what's the problem asking for? And Ian said about stating it carefully. Sometimes that takes a while to work it out, what it's actually about. But understanding the problem is a really important aspect of any piece of mathematics. Secondly, how am I going to do it? In my experience, people are very quick in maths lessons to jump in and solve a problem before they actually think about what they're doing. It helps to take some time, don't rush, think about it. So in this case, am I going to act it out? Am I going to draw a diagram? Because there's some nice diagrams you could have drawn for that particular high-fives problem. Am I going to just think about the structure of it mathematically and see if I can work out a way of doing it and get a formula? Am I going to look for a pattern and start with 2 people, then 3, then 4, then 5, then 6 and see what's going on? There's lots of different ways of doing it.
I
Think about it. Yeah.
I think one of the important things, and especially with kids, but that actually applies to adults as well, is you actually need some playtime. So if you actually want to devise a plan on how you're going to solve a problem, but if you know nothing about it, sometimes you actually just need to play so you start getting a sense of what it might be about, and then you can start devising the plan. So do allow some playtime.
And when you come to the tutorial this week, or for those of you listening online, when you have a look at some of the tutorial questions that are on LearnLine, there's a few problems there which all need just a little bit of playtime to start. Just thinking about what the problem's actually about and doing some experimenting. Polya's 3rd step was that, do it. Carry it out. In whatever way you've kind of thought this is a good way to solve it, do it. Try it. See what happens. See if it gets you anywhere. If it doesn't get you anywhere, try something different. But do it. And his 4th step, which is really important, is that. Look back. So in the case of this particular question with the high-fives, we look back at the end. We had 2 different answers because we had 2 slightly different ways of interpreting the question. To do it effectively, we had to have people talking to each other and saying, here's how I did it, here's how I did it. But that looking back and kind of verifying that that solution actually makes some sense is really important. That's Polya's 4 steps. Here's another way of looking at something very similar. Hadamard was a mathematician about the 1920s, I think. who wrote a book called The Psychology of Invention in the Mathematical Field, or some convoluted name like that. But what he did was he wrote letters to famous mathematicians, including Einstein, and said, how do you solve problems? What do you do when you solve a problem in mathematics? Almost universally, really famous mathematicians said they did these things. They started off by just getting prepared. They played with the problem. So that's a bit like Polya's understand the problem. They just played. They got themselves ready for doing it. Lots of experimenting. Then they had this really interesting word, this really interesting bit of problem solving. When you've got a really hard problem, Hadamard called it incubation. So when eggs are hatched, they're incubated for a while and nothing happens. Almost universally, famous mathematicians said, we think about a problem, we play with it, and then we just leave it for a while. And you kind of have it turning around at the back of your mind, and you just sit on it. I think that's a really interesting thing to think about in terms of teaching a class of children. For those of you who are middle school teachers, or going to be, I can just imagine talking to a class of year 8s and saying, right, don't say anything for the next 15 minutes, just let the problem incubate. Not entirely sure how well that would go, but often we rush into things and try and do it too quickly, and sometimes just letting it sit is a good idea. One of the things that I used to do a lot when I was teaching was end the lesson, not by summarising everything that we'd done, but by leaving a problem and saying, go home and think about it. Not many kids do, but some will, and just leave it. Leave things hanging that people have to think about. It's a nice little strategy for promoting some mathematical thinking. The third phase that Hadamard identified that most mathematicians experience was illumination. That, now I get it. Happens to me when I'm riding my bike sometimes. If I've been playing around with a problem and I go for a long bike ride, these things just churn around in the back of your mind. Yes, that's it. Doesn't only happen in maths, I'm sure it happens everywhere, but it particularly happens in maths. Yes, I've got it. And this is Polya's looking back phase, this is Hadamard's fourth phase, verification. Am I sure that that's now right? Now that I've got this brilliant idea, does it all fit together with what I know? So that's Hadamard's view of solving problems. This is some research done by a mathematics education researcher rather than mathematician by the name of Alan Schoenfeld from the States. Schoenfeld's done lots and lots and lots of work on how children think mathematically, and particularly about problem solving. If you're into reading about problem solving, just look up Schoenfeld on the web and you'll find lots and lots of stuff about what that he's written about. One of the bits of research he did was, what do students think problem solving is about in mathematics? Here are some of the things that kids said about problem solving. So if you've ever watched Letterman, this is top 10. The number, I don't know whether this starts with number 1 or number 10, it doesn't really matter. This is one. Maybe have a guess. What do you think they say about problem solving? These are kids in class. Sorry?
Finding an answer?
Yeah, not what is it, not what it's like to solve problems.
Hard.
Hard. Oh well, hard comes there somewhere. This is one of the things that all children believe, that most children believe, that there's one right answer. Number 2, similar to that.
Difficult?
A bit like one right answer, one correct method. Here's the next one. Too hard will come up in a minute. Third one. Problem solving in maths is about memorising, not about understanding. Fourth one. Have to do it individually. Number 5. If you can't solve it within 2 minutes, you can't do it, it's impossible. Number 6. It's too hard. Number 7. It's irrelevant. I want to challenge all of those. Often in mathematics, there isn't one right answer. There is for a particular question perhaps, but sometimes You can actually have several different answers if you open up the question, and we'll talk about that in tutors. There isn't always one correct method, in fact hardly ever. Mathematics is about understanding rather than memorising. It's not individual. Sometimes things do take a long time. It's not too hard, and it's not irrelevant. That's about the irrelevance